under your fraction notes, write the little subtitle here, which is, children, which is reducing before you multiply. This is also known as AKA, also known as cross-canceling. I can't even spell it. Canceling. Is there two L's in cross-canceling spellers, people? No? Or no? Yes?
Either way.
Is it? Are you 100% sure? How do you know that?
She's smart.
She's smart.
Yeah, she is.
She might just call the rest of us less than smart.
Yeah,
Here is the example that you could and should write down here. I'll write this down. 2/3 times 3/4. In this case, it's not really such a big deal, but if you were asked to do this problem as it stands right now, before we talked about this lesson, you simply would take 2 times 3, right, and get 6, and 3 times 4 and get 12, correct? And then you'd say, well, that can be reduced, so I would divide them both by what? 2, somebody said I like that, because it's, and then you'd get 3 over 6, and then you'd say, oh, I can reduce that because what number goes into those? 3, and then you'd end up with what you should have gotten a long time ago, which is 1/2. Okay? What the book and what you should start getting the habit of doing is this. Life becomes much simpler when you do these problems if, when you look at the original problem, let's go back to the 2/3 times 3/4. There's a handy-dandy little trick that we call cross-canceling, which means it's basically reducing the fractions before you multiply. If you look at, by the way, this should be a 3, yes. If you look at the top numbers with the bottom numbers and say, what same factors do they have, you can actually reduce before you multiply. Here's, for example, 2 and 4. What number goes into both 2 and 4? 2 does. So you could say, okay, 2 goes into 2 once, 2 goes into 4 twice. What number goes into 3 and 3? Well, 3 goes into both of them. How many times? 1 time each. And then when you run out of things to cross-cancel, when you multiply, you get 1 over 2. To which you're going to say, that was kind of confusing, and I don't know if it really helped me a lot. Say that, Lauren. Just say it. Yeah, I agree. Whatever Lauren is thinking and saying, I agree. See, but here would be the deal. If you have 24 over 36, and you are multiplying that, let's say, by 72 over 96, how many of you really want to sit down and multiply 24 times 72 and 36 times 96 and then see and try to reduce those things and see what goes into them? It can be kind of a long, kind of tedious process. But if you look at these and you do what we say, cross-cancel or reduce before you multiply, it can be any top with any bottom. If you look at these numbers, what same factors do any top ones have with bottom ones? And there is no wrong answer as long as it is a factor. Lauren would say,
12 goes into 24 and then
okay, 12 goes into 24 twice. 12, if you don't know, goes into 96 8 times. Okay? What else?
2 goes into both of them.
Who?
2 goes into
Well, Madison says 2 goes into both of these, so you could do that. 2 goes into 2 once, and 2 goes into 8 4 times. What else? Joseph. Nobody sees anything else? Come on, people. There's lots of, there are multiple answers here, Grace.
4, 36, 72, 9.
Okay, 9 goes into 36 4 times, 9 goes into 72 8 times. More.
4 goes into 8.
and what?
And 4.
Does it matter which one? It doesn't. 4 goes into 8 twice, and 4 goes into this one once. What else?
1 goes into 4.
Huh?
1 goes
No, you can't. 1 doesn't change anything.
2 goes into
2 goes into 2 once, 2 goes into 4 twice. Anything else, I'm left with a 1 and a 1 and a 1 and a 2. When I multiply all that out, I get 1/2, which is what the answer will be. If you multiply 24 times 72, what do you get? 8, 28, what's that? 144, 8, 2, you get 1,728 all over 36 times 96? That's garbage. 6, 3, 54, 57, 0, 18, 127, 28. I don't even know if I'm doing this right, but it isn't doing it. 6, 4, 3, 4, 5, 6. Now, for you to sit down and try to reduce that, I mean, you're going to spend a little bit of time. It's just simpler to reduce before you multiply, and then you don't have to worry about doing it. By the way, I do know I have this right because of what? How do I know I have this right? Anybody? Connor?
The digits are even and everything else.
Well, just even digits doesn't tell me that. I know this fraction equals 1/2. Is 1728 half of 3456? Can anybody do that in their head? What's half of 34? 17 half of 56? 28. Yeah, that's right. Got that? Yes, Mr. Hahn. I think you're seeing the light here. Look at this. Now, what about with division? Somebody say that.
What about division?
Well, here's an example of division. Look, 9 over 10 divided by 1 1/5. Okay, the cross-canceling works, but you have to wait until you make it a multiplication problem first. So you have to do the steps we do for multiplication. What happens with division? Well, the first thing I'd have to do is make this improper, correct? Which is what, Chase?
9 times.
No, well, yeah, make this improper for me. What's 1 1/5 as improper?
6/5.
6/5. Now, how do I divide by fractions? Cassandra Melas?
You have to flip this.
Flip the second one, so this is 9/10 times 5, 6. Once you get it to be a multiplication problem, then and only then can you cross cancel or reduce before you multiply. And if you look at this, what number goes into what stuff there? Crossing? What can I reduce? What can I cross cancel there?
3 goes into 9.
3 goes into 9 3 times, and 3 goes into 6 twice. What else? There is more. If you do all the cross canceling first, you never have to worry about reducing at the end. Connor, what else?
5 goes into 5 once.
And in the
10 goes into 5 once. I mean,
10 twice. Now, please note you can't cross cancel bottom things with each other. It has to be bottoms with tops. Nothing else cross cancels, so you remultiply and you end up with 3/4. 3/4. One more example, you say?
One more example.
I know, but that takes away all that work time. 1 1/2 times 2 2/3. Can I cross cancel? Can I cross cancel these 2's?
No.
Not until you
Make them.
make them improper. You got to get them improper first, which is what? 5/2 times, what's that? 6, 7, 8/3? Is that correct?
Yeah.
5? No. 3 over 2. 3 halves.
Oh, yeah, 3/2. I'm sorry. And then what cross cancels? Gianna, what cross cancels there? Do you see something for me? Tops and bottoms? Common factors on top. Things that can be divided both top and bottom. Fine. Which one? Yeah, 3's going to each other at one time. That's one of them. And the other one would be, Joseph?
two goes into 2 once.
And 2
8
goes in,
goes into 2 4 times.
2 goes into 8 4 times, yeah. And then we multiply, you get 1 times 4 is 4, and 1 times 1 is 1, so the whole answer ends up being 4. Thoughts on that? I was very excited about that.